Hello students, this is Dr. Milne. I'm going to be talking to you a little bit about Lab 1 and a little bit of an introduction into what you'll be doing in Lab 1. And so Lab 1 is largely going to be about science versus pseudoscience. And we need to be able to differentiate the two. And so we need to talk about what science is and what pseudoscience is, because there are lots of different categories here. So when thinking about science, this can be defined in many ways, but I like to use 6 different words that combine, the first letters combine to make an acronym, which is POTENT, and gives a sense of science is very powerful, very potent, and these it's a good way of remembering how to define science. So the first P is for predictable. Really, this refers to the predictions, and these predictions that come about from scientific studies and from observations can be tested using science. And so anything that is scientific must be able to be tested. Those predictions must be able to be tested. Also, observable. Science has to be observable by us through our senses somehow. Taste, touch, smell, vision, it has to be able to be observable some way with our senses. Be testable. We have to have the means to test this phenomenon, whatever it happens to be. Also, the results should be repeatable. And so when you say expected, what we mean is that the results of these experiments can be done over and over and have the same result over and over. Natural. So the only things we can test in science are within the natural world. Nothing supernatural can be tested here. And then finally, tentative. So in other words, the results of science can always be revised. If another experiment is done and it is seen that these results are actually incorrect, then science can be revised and a new hypothesis and prediction and conclusion can be made from that new experiment. So POTENT is our acronym that we're going with. And so the general scientific method is shown here. So basically, we generally start at the top here, make observations. And you see something in nature, and you can make an observation about it. This leads to a question, which can lead to a hypothesis. This hypothesis can then lead you to creating a prediction of some kind. And then you actually test that prediction. Okay, so gather data to test predictions. And so this is where experiment comes in. Here we have a little bit of a cycle where that prediction, after it is tested, it can either be accepted or rejected. If it is rejected, you can refine and change your prediction and then test it again. If it is accepted, you can then use that acceptable result to form new theories or new ideas or new predictions. Okay. When it comes to science versus pseudoscience, we have to understand first what science actually goes through to actually be considered real science. And so here's a graphic that I saw recently that tells you a bit about what science does to actually get accepted by the general scientific community. And so I won't go through all this in great detail, but it's very interesting to look at here. So basic science is published in legitimate scientific journals with peer review. And so let's talk a little bit about what that entails. So step 1, he says, get an education. Usually the scientists who are publishing in these journals are ones who have at least a bachelor's degree in a particular field. Usually they're scientists that have a PhD, sometimes with a master's. And so you have to get an education first, though sometimes you can be an undergraduate student and get your name on publications, as happens at UIndy as well. Number 2, you conduct research. Of course, we talked a little bit about last slide, doing a scientific experiment of some kind. You write it up, you submit that to a journal. Of course, we're only talking about legitimate scientific peer-reviewed journals here, not predatory journals, which I'll talk about in a second. The journal editor checks it, and then it goes to something called peer review. Peer review is where other scientists anonymously check that work. These are usually scientists who don't know who you are, who do not know anything about your study, and are coming into this blind. Usually they are anonymous, and so they will check your work, and they will read through your paper, and they will try to determine if there's anything wrong with it, and they'll give reviews back to the editor, and then that's where number 7 comes in, the decision. Based on the peer reviews, the decision is either they reject it, they want major changes, major revisions, minor changes, minor revisions, or generally just straight out accept it, which basically never happens. You get your paper back, you have to revise it, you have to maybe add data, you have to maybe do more studies, you have to maybe change things you say, change conclusions that you drew from your results. And then number 9, you resubmit it. And then eventually, if everything goes well, the reviewers look at it again, they like it, it's accepted. However, when it's accepted, we don't get anything for it. There's no money involved. There's no monetary compensation for this. After publication, oftentimes that paper is cited by other scientists saying, our study builds upon this past study. And that's basically how real science works. Keep in mind that I mentioned those fake predatory. Some journals out there that are legitimate and others that are fake. And there are a lot of fake journals now actually being propagated because oftentimes they'll ask for a publication fee. And so researchers will think that this is a real journal, pay money to get their papers published, and then realize it's fake, and they've basically paid money for nothing, and almost no rigorous scientific process behind this. So there are a lot of predatory journals out there that you have to watch for as well. And so those do not publish scientifically sound papers. So let's talk about pseudoscience or non-science then. What's the difference then between what I was just talking about and what non-science is? Well, non-science can take several different forms. The first is emerging science. Emerging science is also called near science. And near science, these studies often fit some of the potent criteria that we talked about, but not all. And one of the examples of this is mental telepathy. There's been some recent studies that have shown that mental telepathy is actually possible in certain scientific conditions or certain experiments, but is not fully fleshed out with all these different criteria. It hasn't been fully researched and fully repeated. And so there is some credibility to mental telepathy, but it's not fully fleshed out yet. So at the moment, it's considered emerging science. Non-science is basically a scientific or a non-scientific category that doesn't meet any potent criteria. It could sound reasonable, it could sound logical, but it's just scientifically tested. Usually we consider non-science realms that are outside the boundaries of science. So for example, religious beliefs. Religious beliefs cannot be scientifically tested, so they're just considered non-science. And then the last one over here, false science, also called pseudoscience, the dangerous category, because this category is basically studies, often in quotes, that are portrayed as legitimate science, but they are not. Oftentimes they fail or they fulfill some potent criteria, but often fail others potent criteria. One of the examples is astrology. Some people who are big believers in astrology, proponents of astrology, often talk about it as being scientific or as being real. But when you really dive into some of the potent criteria of astrology, it fails on several accounts. And so one thing I'd like to mention real quickly here is I mentioned non-science and religious beliefs are not scientific. And one of the mistakes is that, well, science is basically saying that these things are not real or are false. But that's not true. What we're saying is, what scientists are saying with things like religious beliefs and non-scientific criteria, is that they cannot be tested. It doesn't mean that they are wrong. It doesn't mean that they are false. It doesn't mean you cannot believe in them. It just means that they are not outside the boundaries of science. Okay, science doesn't say yes or no or true or false for these categories. They're just basically not tested. Okay. And the last thing I want to mention is this kind of falls in the realm of misinformation. In today's society, we have a lot of misinformation, and spotting misinformation is also quite important. And science, oftentimes, this misinformation is in the form of pseudoscience. And spotting misinformation and pseudoscience within the media can be difficult. And so there's this article that talks a little bit about this. And basically some of the tips to this are always be skeptical when you're reading something, making sure that it seems real. If it doesn't seem real, or if it seems too good to be true, it usually is too good to be true. Understanding the misinformation landscape is important. So in other words, knowing what has been found to be misinformation, what sites have been seen to be or have a history of being misinforming people is good to know. Don't get pulled in by emotionally charged topics. Oftentimes, sites that have misinformation use emotionally charged topics to get people to read their articles. It's good to investigate using other sources. And of course, when talking to these topics, don't be rude, or being kind is always a good thing. Okay, so when it comes to your lab itself, I'm just going to go through this real quick for the first activity. This is going through the 6 categories, POTENT, and basically I'm giving you a few of these terms, and you're going to determine if these terms satisfy those criteria and why. Okay. For the second bit here, qualifying a statement, we're going to go through some of the non-science, emerging science, non-science, pseudoscience. I want you to write down a statement of some kind. This statement is something you can believe to be true. There is a big ball of a big star in the sky, and we call it the sun. Or something you believe not to be true. As it says here, the Loch Ness Monster has existed in Scotland for millions of years undetected. It can be any of these terms that you think could be scientific or could be scientifically examined. Okay. Once you have that, indicate your opinion. I think this is scientific or non-scientific. It can be either one. And then go through each of the criteria, the potent criteria, and explain or demonstrate if each criterion is satisfied. And so you can say if it is satisfied, it's within the realm of science, or if it is not satisfied, it is outside the realm of science. Okay, and then at the end of that examination, you can come back to your question again, and after reviewing all these criteria, you can finally say, basically, on the basis of these criteria, I now consider this either scientific, proto-scientific, pseudo-scientific, or non-scientific. Okay, proto-scientific is the same as the emerging science. Okay, and then sort of explain or justify why you think that is. The third activity is just quickly going through some of these claims and basically stating one of the potent criteria that you think is being violated by this claim. So, for example, the claims that next year will bring many drastic global changes. All right, one scientific criteria that is being violated is what? Okay, and so go through the potent criteria, think of one, at least one, and write that one down. Okay, and the last activity here is basically a little of self-examination. There's this website here, skeptic.com, and it basically talks about a list of lots of pseudo and non-scientific phenomena, and it goes through and explains a lot of them that are commonly believed in today's society. And it's interesting for you to go through that list and try to see, is there anything you believe that is actually pseudoscientific, that's sold by some type of peddler of pseudoscience. These can either be frauds or hoaxes, things like cryptozoology, new age science, paranormal activity, things like that. And so list some of the things you actually believe or have when you were a kid or when you were younger. And then lastly, use the potent criteria to analyze each phenomenon, or if it's a lot, maybe just a few, and basically explain how the potent criteria actually show that this is not real science. Okay, that's it. That's our lab. Okay, if you have any questions, be sure to email your instructor, ask them any questions you may have. And this is me signing off. Bye.